All right, let's pull back the curtain on the digital world and take a look at its hidden engine. And no, we're not talking about some super dry, complicated code. We're going to explore the secret language that powers pretty much every single app you use and love. That language is SQL. Let's dive in.
I mean, really think about that for a second. How on earth does a platform like Instagram keep track of every photo, every like, every single comment and follower? Or how can Spotify pull up that one specific song you're looking for out of like 80 million tracks in less than a second? It totally feels like magic, right? Well, it's not. It's architecture. You know, the one thing all these huge platforms have in common is just an unbelievable amount of data. Every user, every post, every single search you make, every song you listen to, it's all just information. We're talking mountains and mountains of it, and it's growing every single second.
So to manage this digital explosion, they all rely on the exact same fundamental tool. It's this powerful, kind of elegant language that brings order to all that chaos. It makes sure every little piece of information is exactly where it needs to be. And that language is SQL.
Okay, so how do they actually do it? How do you organize information on a planetary scale? Well, it all starts with one core concept, the database. At its heart, a database is really just a place to store information in a super organized way. But, you know, forget about some clunky old filing cabinet. I want you to imagine one that's infinitely large, it's perfectly indexed, and it can find any file you need in a fraction of a second. That's a database.
This is a brilliant way to picture how it all fits together. So the database, that's the library. It holds all the books, all the data. Now, you don't just wander in and start grabbing things off the shelves, right? No, you talk to the librarian. That's the database management system, or DBMS. And how do you talk to the librarian? You use a special language they understand perfectly. SQL. That's your request.
So what does the inside of this digital library actually look like? Well, it's surprisingly simple. The information is stored in tables. And hey, if you've ever used a spreadsheet like Excel or Google Sheets, you already know what a table is. It's just a grid of rows and columns. A single database can hold thousands of these tables, each one organizing a different type of information. So we have our library and we have our librarian. Now it's time to actually learn how to speak their language. It's time to learn the basics of SQL. And trust me on this, it's a whole lot more straightforward than you might think.
The official name is Structured Query Language, or SQL. And query is really just a fancy word for a question or a request. So it's just a structured way of asking questions. It's been the industry standard for decades, and believe me, it is used everywhere. And now this is the absolute key right here. Don't think of SQL as some hardcore programming with a bunch of confusing symbols. Think of it more like you're writing simple, clear commands in a way that's really close to plain English. You're not building some complex machine, you're just telling the data what you want it to do.
Okay, enough theory. The best way to really understand SQL is to just see it in action. So let's build something. We're going to create our very first table, right now, from scratch. Our goal is simple. We need a place to store information about some students. And let's say we want to track 3 things for each student: a unique ID, their name, and their age. So this is our blueprint, an empty table that we'll call students, with 3 columns: ID, name, and age. This structure, this design, it's often called the table's schema. Now, let's write the SQL command to actually build this thing. And there's the command. See how readable that is? Create table students. I mean, it does exactly what it says. Then inside the parentheses, we just define our columns. We tell it that the ID will be an int, which is just an integer, a whole number. Name will be a varchar, which is just text up to 50 characters long, and age is another integer. We're going to circle back to that primary key part in just a minute. That is the secret sauce for keeping our data perfectly organized. An empty table is a good start, but it's not very useful, is it? So let's move on to the next logical step. We need to put some information into the table, and then we need to ask the database to show it back to us.
And again, just notice how much this looks like an English sentence. We're telling the database to insert into our students table. Then we list the columns we're filling, ID, name, age, and then we provide the values in the exact same order: 101, Amen, and 26.
And just like that, boom,
The command adds a brand new row to our table. We've gone from an empty blueprint to a structure that's holding real organized information. The process is immediate and it's really powerful.
Okay, so we've put data in, but how do we get it out? How do we ask our librarian to show us the contents of our new table? This is probably the most common thing you'll ever do in SQL.
And the command for it is beautifully simple. Select asterisks from students. That little star, the asterisk, it's just a universal shorthand that means everything or all. So this command literally translates to select all columns from the students table. Simple, right? But to make sure this system works without creating a total mess, we need some ground rules. Right, so in order to do all the really powerful stuff later on, like connecting different tables together, we have to have rules. Solid, unbreakable rules that keep our data clean and reliable. And in SQL, these rules are called constraints. Constraints are basically just safeguards you attach to your columns to prevent mistakes and bad data. And these constraints are what make complex operations, like linking tables together with a join command, possible. The most important constraint of all is the primary key. Remember that from our create table command? Now we're going to see why it is so important. This comparison shows you exactly why it is so critical. Without a primary key on our ID column, what's stopping us from accidentally adding two different students with the exact same ID number? Well, nothing. It would create total chaos and confusion. But with a primary key, the database itself enforces the rule. It will literally reject any attempt to add a duplicate ID, which guarantees that every single row is perfectly unique. It's this guaranteed uniqueness that lets us reliably connect data across different tables. So that's the big takeaway. A primary key gives a column two superpowers. Its values must always be unique, and they can never, ever be empty, or what programmers call null. It means every student must have an ID, and every student's ID must be different from everyone else's. This one simple rule is the absolute foundation of clean, reliable, and most importantly, connected data. From creating tables to asking them complex questions, it all comes down to these core ideas. This isn't just about code, it's the organizational blueprint for our entire digital lives. You just learned how the modern world speaks to itself. So the only question left is, what conversation are you going to start?